Today we're going to look at the concept of pH. Hopefully you remember from our discussion on the properties of acids and bases that acids have a pH that's less than 7. And so things like stomach acid, vinegar, coffee, tomato, lemon, batteries, milk even is all acidic because they have a pH less than 7. And then basic has pHs above 7. So our antacids that we take to settle a sick stomach, soaps, drain cleaners, bleach, ammonia, baking soda, even your blood is basic. Now, water we say is neutral, or pure water is neutral, because it has a pH of 7. And so when we're talking about pH, we're talking about the hydrogen concentration, how much H plus is in our solution compared to, and we usually compare it to water to figure out if it's acidic or basic. So the formulas that you're going to need are given to you on page 3 of your reference tables. And they are here now on the right-hand side. And I know that it has log in it, and some of you might start thinking of math class again and logs, but I promise you this is really easy. And as long as you can add to 14, you don't even need a calculator. So what we have are the different relationships involving pH. pH plus pOH is 14. So here we have the concentration of hydrogen and then the concentration of hydroxide. And when we add those together, we get 14. To find pH, you would do the negative log of the hydrogen concentration. Now, if you remember, log just means base 10. So whatever the exponent is what the pH is. And then it's negative because we're dealing with such small values. So to find pOH, we would take the negative log of the concentration of hydroxide. So hydrogen gives us pH, hydroxide gives us pOH. We can relate the two concentrations of hydrogen and hydroxide by multiplying them, and they would always give us 1 times 10 to the negative 14. That's called the equilibrium constant for water, and I know we haven't talked about equilibrium yet. But those two, the concentrations, the exponents should always add up to be negative 14. So we're always going to have 1 times 10 to something, and then the exponents of our concentration should always add to be negative 14. And then to find the concentration, if we know the pH, we would do inverse log or second log on the calculator, and you would get 10, and then you would raise it to the negative pH. Notice that we have that negative back there because, again, the concentrations are very, very small numbers. So let's look at some examples. So here we're given 1 times 10 to the negative 4th molar, so there's my unit of concentration, of sodium hydroxide. Now, sodium hydroxide, being an ionic solid, will break apart in water to form ions, so it's an electrolyte. And so we can get our hydroxide concentration because that's what's given to us, because that's what that's breaking into. So we have our formulas on page 3 that we're going to use. Our given is hydroxide, so we can go ahead and fill this out to be 1 times 10 to the negative 4th. Then if we want to find hydrogen concentration next, and it really doesn't matter the order you go here, then we would look on page 3 of our reference table, and we're going to use this formula here. So when I multiply these two concentrations, their exponents would add to be negative 14. So if I want them to add to be negative 14, and hydroxide's already a negative 4, that would mean my hydrogen is a negative 10. So again, it's always going to be 1.0 times 10, and then these exponents have to add up to 14. That's what page 3 is telling us. The unit is always molarity. Now let's say we want to find pH. Well, pH is the negative log of H, so it's based on our hydrogen concentration. So we're going to look at times 10 to the negative 10. Remember, log is base 10, so the base of 10 is negative 10. However, we do the negative log of it, so the negatives kind of cancel out. So the pH then is just the exponent 10. To solve for pOH, you have a couple options. You could use the pOH is equal to the negative log of the hydroxide concentration. So you have hydroxide here, so you want to make sure you're looking at your concentration of hydroxide. So we look at the exponent, and that becomes our pOH. So the exponent gives you pH or pOH. To figure out if the solution is acidic, basic, or neutral, you have to look at the pH value. That's what we judge it on. So since the pH is 10, which is higher than 7, it's going to be basic. Remember, basic is when the pH is greater than 7. Let's look at another example. Here we're given, there's our formulas. Here we're given the pH of 8. So I can automatically fill in pH is 8. Where do I want to go next? Let's go pOH. Again, it doesn't matter the order you do these in. So if we want to find pOH based on our pH, we would look at this formula. So pH plus pOH equals 14. So if the pH is 8, pOH has to be 6. They have to add to 14. To find hydrogen concentration, we would use that H plus is equal to 10 raised to the negative pH. So really we're just doing 1 times 10. That's what that 10 represents. And then we're going to say negative whatever the pH is. Well, the pH is 8. So we would say 1 times 10 to the negative 8. So those exponents should always match. Now we want to find hydroxide. We have 2 ways we could do that. We could use that Kw formula and know that the exponent has to add up to negative 14. Or we could base it on pOH is equal to 10 raised to the negative pOH. So the pOH is telling me my exponent, and it has to be negative. So we would say 1 times 10 to the negative 6 molarity. So pH and pOH add up to 14. The exponents on my 2 concentrations add up to negative 14. So that's why 14 is the key number here. All right, to figure out if it's acidic, basic, or neutral, you need to focus on the pH. And since pH is equal to 8, which is greater than 7, this is basic. Now, it's not as basic as the previous example because the other one was 10, so it's farther away from 7, so it's not as basic, but it is still basic because it's greater than 7. Let's look at another one. Here we're given HBr. So which one of these do we have then? Well, H would give us H. So this is our concentration of hydrogen. Remember, acids always start with H, and acids break apart in water. They form these ions in water. So we have H plus and Br minus. We don't care about the Br minus. We're focused on the H plus. So our hydrogen concentration then is 1 times 10 to the negative 5. All right, so then what do we want to find next? pH. We're going to turn to page 3 of our reference table, and we're going to focus on this formula. pH is equal to the negative log of H plus. So remember, log is base 10, so it's simply the exponent of the concentration. So pH then would be 5. All right, what do we want to find next? How about pOH? Remember, 14 is the key number. So if I have my pH of 5 and I needed to add to pOH to equal 14, 14 minus 5 gives us 9. So we have our adding 5 and 9 together gives us a total of 14. All right, so let's find hydroxide. Remember, hydroxide is based on pOH. And so my pOH value would be negative exponent of my concentration. So we have 1 times 10 to the negative 9. Exponents add up to negative 14. pH and pOH add up to 14. So is this basic, acidic, basic, or neutral? Remember that it's based on pH. So if I have a pH of 5, 5 is less than 7, so this is going to be acidic. It's acidic because the pH is less than 7. Let's do one more example. Here we're given a pOH of 11. There's our equations given to us on page 3. So our given is pOH, so we can go ahead and fill that out as 11. To find pH, we're going to add them together to equal 14. So if I already know pOH is 11, 14 minus 11 tells me that my pH is going to be 3. To find the hydrogen concentration, I'm going to use the formula here, where it equals 10 raised to the negative pH. So remember, it's just 1 times 10, that's what that means, and then you have your negative pH. So we have 3 as our pH, so that's going to become our exponent, and we're going to make it a negative exponent. To find hydroxide, we're going to do the same type of thing, but we're going to use pOH instead. So if my pOH is 11, my exponent then has to be negative 11. So we get 1 times 10 to the negative 11. So my exponents add up to negative 14. My pH and pOH add up to 14. So to figure out if it's acidic, basic, or neutral, remember we look at pH. You can only look at that value. So since 3 is less than 7, it would be acidic. So it's acidic because the pH is less than 7. Please reach out to me if you need help or you have any questions. Try the classwork and see if you can repeat the process.